on houses with a car that's on fire inside the garage, or even a house fire that's well started that we don't have the personnel to make entry yet. With the Cobra monitor, I'm able to direct a stream efficiently straight into the seat of the fire and get a good knock on the fire with just myself and an engineer. The accuracy of the Cobra is far superior to anything we've used in the past, and the sheer mobility of it. It's able to move in ways that no other monitor has ever moved for us before. The remote control is a real safety device for us for being able to go out in the field and operate it accurately, put the water stream where we need it to be without putting a person on the truck, without having to radio back to an operator on the truck.
I'm Chris Martin, and we're getting down to the brass tacks and hard facts of the new Chief XD nozzle. The Chief nozzle has been an industry standard for constant flow nozzles for decades. The product, however, has been largely unchanged since the mid-90s. Taking careful attention to industry feedback, we've redesigned this tough product to make it even tougher, what we're calling XD for extreme duty. Improvements include, as standard, a full round ball for maximum stream quality and efficiency. Redesigned handle that's more ergonomic with improved attachment points that are even more durable. Color-coded grip insets that can be personalized to your liking. We've removed all the stickers and everything is laser etched, so there's nothing to peel off or scratch. And as standard, the plastic spinning teeth have been replaced with stainless steel teeth for maximum durability. We've taken what was the industry standard for toughness and made it even tougher. Care and attention to detail has been taken to ensure there's been no compromise of the waterway design, and the stream reach and quality is that which you've come to expect from Elkhart brass products. The new Chief XD nozzle meets or exceeds stream quality expectations of our Chief and what you would find in a high-performance product.
I'm Jerry Knapp. I'm going to give you the brass tacks and hard facts about how the air movement caused by your nozzles affects your fire attack process. Air movement caused by air entrained by our fire streams during an interior fire attack is an important but often overlooked part of a successful fire extinguishment operation. There are many different air movement patterns in the fire compartment depending on if the nozzle is inside or outside the fire room. Air entrainment does start at the nozzle. Typical nozzle operation and movement during a fire attack both distributes cooling water on the burning fuels and surfaces and also creates air movement during the fire attack. So let's take a look at some of the brass tacks and hard facts of how air entrained by our fire streams affects your interior aggressive fire attack. We use mason twine and survey tape to indicate gross direction of airflow and relative intensity. Although the water droplets from the hose stream hit the twine and streamers and disrupt their accuracy, they can be used to understand the basics of very complex air movement inside the fire room. As this video shows, a solid or a straight stream off a combination nozzle moves very little air if the nozzle is held in a fixed position. But in a real fire attack, we must move the nozzle to distribute the water onto the burning surfaces. Movement of the nozzle, as we have been taught in an O, N, or Z direction, causes air movement into and out of the fire area and around the area of the nozzle and the hose stream. This has a potential to stir up the environment as the water is cooling both the surfaces and the burning fuel in the room. This is demonstrated by the wind streamers moving back towards the nozzle team. Obviously, if this is a small room in a house with limited fuel, the water from the stream overwhelms the fire quickly and the result is usually a successful fire attack. If this is a more fair firefight other than a residential occupancy, these chaotic and violent air currents of heated, moist air and steam may cause our aggressive push to be halted while the fire continues to spread into unburned areas. You can see the wind streamers are being directed back toward the nozzle team. That little drop of water may have been heated or turned to steam and may be heading your way. In contrast, a fog stream entrains massive amounts of air. Some of this air comes in openings behind the nozzle, but most comes from directly behind the nozzle where the water flowing out creates a negative pressure. Both these create chaotic air movements in a room. Consider that this fog stream is pushing around 10,000 cubic feet of air per minute. We used to say if you pointed that fog stream toward an opening, the fog would drive all the products of combustion out. As evidenced here, we know that's not true. Let's take a typical room in a house, 12 foot by 16 foot by 8 foot high. It contains 1,536 cubic feet. If our solid or straight stream is moving 7,000 cubic feet of air per minute, it will cause air currents similar to those shown here. Your solid or straight stream operated in an O, N, or Z pattern has the energy to move the entire volume of air in that room and the heat and products of combustion it contains in 15 to 20 seconds. If you have a vent opening ahead of the hose line, moving a lot of air and stirring up the fire environment, the simultaneous extinguishment and cooling and the movement of that heat and products of combustion out the window is good and good for your fire attack. If there is not a vent ahead of you, the less air you stir up, the better. Here's an interesting demonstration of how much actual energy and how powerful the air is entrained by your hose stream really is. There is enough energy transferred from the pump to the stream to move the nearby air fast enough, hard enough, and consistently enough to break the surface tension of the water, cause it to form a water spout as shown here. Our fire stream contains a large amount of energy and can have a huge impact on the fire environment. Consider the following data recently published by Underwriters Laboratories. The title of the research is The Impact of Fire Attack Utilizing Interior and Exterior Streams on Firefighter Safety and Occupant Survival. As this bar graph shows, the air movement caused by one type of nozzle held stationary and then the same nozzle moved in a typical fireground fashion shows vastly different amount of air movement. It shows that our commonly used nozzles and fire tech techniques move considerable amounts of air inside the fire compartment. So what do all these hard facts mean to us on the fire ground? First, we must always consider the massive amounts of air our fire streams have on the fire attack process while inside the fire compartment, with special consideration toward the ventilation condition. Second, we can see in these very simple tests that a solid or straight stream being moved in the patterns we have been taught have similar air movement volumes to that of a fog stream. And third, when your fire stream ends on a far wall, it will create certain air movement patterns. When you move that across the wall and the stream goes out a window or door, those air movement patterns change drastically. It is also important to apply these air movement facts to our training. Training fires deceptively allow firefighters to get inside and then open the nozzle. Opening the nozzle deep inside the fire compartment in a real fire may produce really bad results. Consider using the reach of the hose stream to cool the room, knock down the fire, and prohibit full room involvement. Consider also revising your training based on these facts. Air entrainment by hose streams and air movement inside a fire compartment, as we have seen, is not simple. There are many variables that make air movement during a fire attack very complicated. Understanding these will help keep you safe on the fire ground.